In this video, we're going to discuss Charles's law. Charles's law is a gas law that involves only volume and temperature. It's a direct proportion between volume and temperature. As the volume goes up, the temperature goes up. As the volume goes down, the temperature goes down. V1 stands for the initial volume in either milliliters or liters. T1 is the initial temperature in degrees Celsius. V2 is the final volume. It can be matching units or not. We may have to convert. T2 is the final temperature in Celsius. In order to use any of these gas laws, we must convert all temperatures to degrees Kelvin. We do that by adding 273 to the given degrees or temperature in Celsius. So let's take a look at an example. Here we have a volume of 425 milliliters of oxygen is at a temperature of 15 degrees Celsius. If the volume was increased to 575 milliliters, what would the new temperature equal? Okay, so remember, it's a direct proportion. If the volume goes up, the temperature should go up also. So let's see what happens. This problem only involves volume and temperature, so it's a Charles's law problem. We're going to go ahead and take the information from the problem and assign them to the variables. My initial volume, 425 milliliters. My initial temperature, 15 degrees Celsius. My final volume, it's increased to 575 milliliters. I'm looking for my final temperature. Before I can substitute anything into the formula, if I'm using temperature, I have to convert it to Kelvin. So I'm going to add 273 to 15 to get 288 degrees Kelvin. Now I'm ready to substitute. I go ahead and I substitute into that Charles's law, and I see I'm looking for T2, which is in the denominator. The easiest way to solve this is to take the reciprocal of both sides. In other words, flip both of those ratios to get this. Now, all I have to do is multiply both sides by 575. There I have it. So T2 equals this nice expression. All I have to do is plug it into my calculator, and I get T2 equals 389.65. So now I have to convert that back to degrees Celsius. I do that by subtracting off the 273, and I get my final temperature is 116.65 degrees Celsius. So let's think. My volume increased and my temperature did also. That's a little sanity check. So now let's take a look at one more example. Here we have a mountain climber with a body temperature of 37 degrees Celsius inhales 486 liters of air at a temperature of -8 degrees Celsius. What volume in milliliters will the air occupy in the lungs? Okay, so this only involves temperature and volume, so I'm going to use Charles's law. Now I need to pick the information out of the problem and assign it to the variables. So this guy is up on a mountain somewhere and he inhales 486 liters of air that's at an air temperature of -8 degrees Celsius. So those are my initial values. And that air is going into his lungs. We're looking for the volume. And his lung temperature, his body temperature, is 37 degrees Celsius. First thing we have to do is convert temperatures to Kelvin. So we convert T1 and T2. Now we're ready to substitute in V1, T1, and T2. We get this. We see that we're solving for V2, which is already in the numerator. So all I have to do is multiply both sides by 310, and I get V2 equals this value. Well, I have to plug that in my calculator. I do that, and I get V2 equals 568.5283 liters. Now you're asking, why did you save so many decimal places? Well, I look ahead into that problem. It says we want the volume in milliliters. So there's 1,000 milliliters in a liter. So I have to take that number and multiply by 1,000. So now I have my answer in milliliters. Hopefully this will help you with your Charles's law problems. Please don't hesitate to ask if you have any questions.